Hello students, welcome to first PUC physics online class. So last class we discussed the concept of the collision and also types of collision, that is elastic collision as well as the inelastic collision. And also we discussed the concept of the laws of kinetic energy in case of a perfectly inelastic collision. Perfectly inelastic collision is nothing but it is if the two bodies are stick together after collision, then that type of collision we call it as a perfectly inelastic collision. Now next onwards we have to derive the very important derivation, that is a derive the expression for the final velocity of a two bodies during completely elastic collision. This is the derivation of completely elastic collision. So this is 5 mark question, very important one, very important question, and this is asked for 5 mark. Now we have to obtain the final velocity of a two bodies during completely elastic collision. Completely elastic collision, what is the meaning of elastic collision? Elastic collision is a collision in which both momentum and kinetic energy both are conserved. Andre total momentum before the collision of two bodies, that should be equal to total momentum after the collision of the two bodies. That condition should be obeyed. And second condition is that total kinetic energy before the collision of two bodies, that should be equal to total kinetic energy after the collision of two bodies. That condition is also should be obeyed. ಎರಡು ಕಂಡೀಷನ್ ಒಬೆ ಆಗಬೇಕು, ಒಂದು ಮೊಮೆಂಟಮ್ ಮತ್ತು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎರಡು ಕೂಡ ಒಬೆ ಆಗಬೇಕು, ಎರಡು ಕೂಡ ಕನ್ಸರ್ವ್ ಆಗಿರಬೇಕು. Now for that let us consider the two bodies. Consider two bodies. Say here there is a one body of mass m1, second body here m2. Assuming that this body is moving with the velocity say v1i and this body is at rest, so therefore v2i that should be equal to 0, and this body collide with this one. First body collides with the second body, and after collision ad nantra, say one body moves along in this direction, another body moves along in this direction. Say here one body, that is the first body, that is m1, is moves like this. Second body having a mass m2 is moving along in this direction. So second body moves with the velocity of say v2f, and first body moving with the velocity of v1f. So v1 is v1f, second body is v2f, and this is a original direction. This is a original direction. Say like this. So we have to explain all the terms now. m1 is the mass of the first body, correct agi nodikolli, mass of the first body. m2 is the mass of the second body. m2 is the mass of the second body. What is v1i here? v1i is the initial velocity of the first body and second body is at rest, so therefore v2i will be equal to 0. So v2i is nothing but initial velocity of the second body. Since this body is at rest, so therefore its velocity will be 0. And now v1f is the final velocity of the first body, and v2f, it is the final velocity of the second body, and this is after collision. So this one is also after collision. So this is the initial velocity first body before collision, collide ಆಗೋ ಮುಂಚೆ ಇರುವಂತ velocity. So this is a terms explanation. Now I will consider this angle as theta1 and this angle is theta2. ಈಗ ಇದು ಇದಕ್ಕೆ ಹೋಗಿ ಕೊಲೈಡ್ ಆಗುವಾಗ ಈ ಬಾಡಿ ಹೀಗೆ ಹೋಗ್ತಾ ಅಂತ ಇಟ್ಕೊಳ್ಳುವ, ಇನ್ನೊಂದು ಬಾಡಿ ಈ ಸೈಡಿಗೆ ಹೋಗ್ತಾ ಅಂತ ಇಟ್ಕೊಳ್ಳೋ. ಈಗ ಸೊ ಆ್ಯಂಗಲ್ ಅನ್ನು ನಾವು θ1 ಮತ್ತು θ2 ಅಂತ ತಗೊಂಡಿದ್ದೇವೆ. Now for that let us assume that the θ1 as well as θ2, that is this angle, θ1 and θ2 is equal to, both are equal to 0 degree. That means ಈ ಆಂಗಲ್ಸ್ ಇರಬಾರ್ದು, ಈ ಆಂಗಲ್ಸ್ ಕೂಡ ಇರಬಾರ್ದು. ದಟ್ ಮೀನ್ಸ್ that body, whenever this body is collide with the second one, it moves along a straight line, assuming that there is no angle. ಇಲ್ಲಿಗ ಆ್ಯಂಗಲ್ ಯಾವುದು ಕೂಡ ಬರ್ತಾ ಇಲ್ಲ, ಸ್ವಲ್ಪ ಓರೆ ಆಗಿಲ್ಲ ಹೋಗ್ತಾ ಇಲ್ಲ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಈಗ ಎರಡು ಕೂಡ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ತಾ ಉಂಟು ಇಟ್ಕೊಳ್ಳಿ. ಈಗ ಸೊ ಇದು ಇದಕ್ಕೆ ಹೋಗಿ ಕೊಲೈಡ್ ಆಗುವ, ಎರಡು ಕೂಡ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ತಾ ಉಂಟು with a different velocity. One is v1f, second body is v2f. So in case of a completely elastic collision, in completely elastic collision, the momentum and the kinetic energy both are conserved. So here I am writing one term. So in completely elastic collision, momentum and kinetic energy both are conserved. Momentum and kinetic energy both are conserved. Now, first of all, we have to write the formula for the momentum concept. Momentum is conserved. Momentum is conserved means, hege baribek now formula. Total momentum before collision, that should be called the total momentum after collision. What is the momentum of the first body? Momentum of the first body, that is given by m1 v1I. What is the momentum of the second body? That will be equal to 0. What is that should be equal to final momentum. This is our total momentum in before collision. We have to write total momentum after collision. What is the total momentum after collision? So total momentum after collision, momentum of the first body as well as momentum of the second body after collision. That is m1, ಈ ಆ್ಯಂಗಲ್ ಅಲ್ಲಿ ಹೋಗುದಲ್ಲ, ಇದು ಸ್ಟ್ರೈಟ್ ಹೋಗುವಂಥದ್ದು, m1 v1f and second one body ಇದು m2 v2f. We can write it as like this. Now we should be equal to m1 v1I, this is 0, so taking this term as left side, so m1 v1f, that should be equal to m2 v2f. I will call this as equation number 1. Correct ನೋಡಿಕೊಳ್ಳಿ. So this is the first equation we obtained, and this is a formula is written on the basis of the momentum, law of conservation of momentum. Total momentum before collision, that should be equal to total momentum after collision. Now second part, kinetic energy is also conserved. So since kinetic energy is conserved, kinetic energy is conserved. Kinetic energy conserved ಆಗಿದ್ರೆ ನಾವು ಹೇಗೆ ಬರೀಬೇಕಾಗ, total kinetic energy before the collision, that should be equal to total kinetic energy after the collision. So what is the kinetic energy of the first body? Kinetic energy of the first body, half into m1 into v1I square. This is the kinetic energy of the first body. Plus, what is the kinetic energy of the second body? Second body, that will be equal to 0, because this body is at rest. That should be equal to total kinetic energy after the collision. Kinetic energy of the first body after collision. E body the kinetic energy, the straight ಹೋಗುವಂಥದ್ದು. So E body the kinetic energy, that should be equal to half into m1 into v1f square. v1f square. Second body the half into m2 into v2f square. So we can write it like this. Now that should be equal to, this can be written as half into m1 v1I square, that should be equal to, say I will taking this term as outside, so left side, half into m1 into v1f square, that should be equal to half into m2 into v2f square. Taking m1, taking half term outside the bracket, so half of m1 v1I square minus m1 v1f square, that should be equal to half of m2 v2f square. So here the half term get cancelled. Now that should be equal to, so here m1 can be taken outside here also, v1I square minus v1f square, v1I square minus v1f square, that should be equal to m2, I will write this term as m2 v2f into v2f, because it is v2f square. I will write it as like this, m2 v2f into v2f. So this is multiplication term. So therefore I will write it as like this, m2 v2f into v2f. ಇದನ್ನು ಯಾಕೆ ಈ ರೀತಿ ಬರ್ತದೆ ಅಂದರೆ ನಮಗೆ ಇಕ್ವೇಷನ್ ನಂಬರ್ 1 ನಲ್ಲಿ ಒಂದು ಫಾರ್ಮುಲಾ ಬಂದಿದೆ ಇಲ್ಲಿ, m1 v1i ಮೈನಸ್ m1 v1f ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು m2 v2f ಅಂತ. ಈಗ ನಾನೀಗ ಈ ಟರ್ಮಲ್ಲಿ by substituting from equation number 1 here, so we can write it as, how we can write it as m1 is taking already outside, so m1 v1i square minus v1i square minus v1f square, that should be equal to m2 v2f can be written as, how, m1 v1i minus m1 v1f m1 v1f, isn't it? m1 v1i minus m1 v1f and into v2f. Say like this. Now this can be written as, that should be equal to, by solving this term, so m1, this is from equation number 1, using equation number 1 we are written like this. So here we can write it as, using equation number 1. Now next onwards we have to solve this one. This term is nothing but a square minus b square. ಇದೀಗ ಫಾರ್ಮ್ಯಾಟ್ ಇದು a square minus b square, ಆ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಉಂಟು. a square minus b square can be written as a plus b into a minus b. So therefore we can write it as v1i plus v1f into v1i minus v1f. We can write it as like this. So here taking m1 as outside, here taking m1 outside, m1 into v1i minus v1f into remaining term is v2f. Now by seeing this equation, m1 get cancelled, this term will get cancelled, and v1i minus v1f, this full term is also get cancelled. So we obtain the final equation as v1i plus v1f, that should be equal to v2f. We obtain the format as like this, v1i plus v1f, that should be equal to v2f. By rearranging the various term, we obtain the final equation, that is v1i minus v1i plus v1f, that should be equal to v2f. I will call this as equation number, say, 2. This as equation number 2. Now we have to obtain the derived expression for the final velocity of the two bodies. That means final velocity is nothing but, one is v1f, second body is having a velocity v2f. We have to derive the expression for v1f and v2f. ನಾವೀಗ ಮಾಡಬೇಕಾದ್ದು v1f ಮತ್ತು v2f ಇದು ಡಿರೈವೇಷನ್. ನಮಗೆ ಬಂದದ್ದು ಈಗ v1i ಪ್ಲಸ್ v1f ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು v2f ಅಂತ ಬಂತು ಈಗ. ಹಾಗಾಗಿ ನಾವು ಈ ಇಕ್ವೇಷನ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಎಲ್ಲಿ ಅದು ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೋಗ್ಬೇಕು ಈಗ. ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ವಿ ಹ್ಯಾವ್ ಟು obtain the expression for the v1f. How we can obtain the expression for the v1f? Just by observing the equation number, say 1, by using the equation number 1. So here in this case, m1 v1i minus m1 v1f, that should be equal to m2 v2f. Here m2 v2f. Substituting the v2f in equation number, by substituting the value of v2f in equation number 1. So substituting equation number 2 in equation number 1. 2 ಅನ್ನು 1 ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಆವಾಗ ಇದು ಹೇಗೆ ಬರ್ತದೆ ಇಕ್ವೇಷನ್? ದ್ಯಾಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ m1 v1i minus m1 v1f, that should be equal to m2 v2f ಇರುವಲ್ಲಿ ನಾವು ಇದನ್ನು ಹಾಕಬೇಕು ಈಗ, m2 v1i plus v1f. ಹೀಗೆ ಬಂತು ಇಕ್ವೇಷನ್. Now we have to solve this one. That should be equal to m1 v1i minus m1 v1f, that should be equal to, taking multiplication, m2 v1i plus m2 v1f. Say bring this term to left side, so m1 v1i, and taking this term to right side minus m2 v1i, that should be equal to m1 v1f plus m2 v1f. Because this term as well as this term is in the form of v1i. v1a term is there in both the terms, and here v1f as well as this is also v2f, so v1f. So this term as well as this term, so we are bringing to one side, so therefore we can write it as now here m1 minus m2 into v1i, that should be equal to, here v1f is common, m1 plus m2 into v1f. So therefore we can write it as formula for the v1f ಗೆ ನೀವು ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ರೆ m1 minus m2 divided by m1 plus m2 into v1i. This is a final equation. First equation we obtain, that is a final velocity of a first body, that is given by the formula v1f, that should be equal to m1 minus m2 divided by m1 plus m2 into v1i. So this is a final velocity of a first body. Now just ಕಾನ್ಸೆಪ್ಟ್ ನಾವು ಹೇಗೆ ಯುಟಿಲೈಸ್ ಮಾಡಿಕೊಂಡು ಹೋದಂದರೆ, ಒಂದು ಮೊಮೆಂಟಮ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿದೆವು ಹಿಯರ್, ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್, ದಿಸ್ ಒನ್, ಆ್ಯಂಡ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿದೆವು. ಸೊ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸೆಪ್ಟನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಡಿರೈವೇಷನ್ ಮಾಡಿಕೊಂಡು ಹೋದೀಗ, ಆವಾಗ ವಿ ಒಬ್ಟೈನ್ ದ ಫಾರ್ಮುಲಾ ಈಸ್ ಗಿವನ್ ಬೈ v1f, ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು m1 minus m2 by m1 plus m2 into v1i. ನೀವು ಇದನ್ನು ಬರೆದು ಕಲಿಬೇಕು, ಈ ಡಿರೈವೇಷನ್ಸ್ಗಳನ್ನೆಲ್ಲ ಜಸ್ಟ್ ಒಮ್ಮೆ ಬರೆದು ನೀವು ಮ್ಯಾಥಮೆಟಿಕ್ಸಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗುವಾಗ ವಿ ಒಬ್ಟೈನ್ ದ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್. Now suppose if m1 and m2 both are equal, what happens? ನಿಮಗೀಗ ಫಸ್ಟ್ ಬಾಡಿ ಮತ್ತು ಸೆಕೆಂಡ್ ಬಾಡಿ ಎರಡರದ್ದು ಕೂಡ ಮಾಸಸ್ ಒಂದೇ ಥರ ಇದ್ದರೆ, if the masses of both the bodies are equal, what happens? Then in that case v1f value will be equal to 0. Why? Because m1 ಮತ್ತು m2 ಈಕ್ವಲ್ ಆದ ಕೂಡಲೇ ನ್ಯೂಮರೇಟರ್ will become 0. Denominator does not become 0, so numerator will become 0. When the numerator is 0, then what happens? v1f value will be equal to 0. So we obtain the final velocity in that case will be equal to first body will be equal to 0. In the similar way, we have to derive the expression for the final velocity of the second body. Now we get the derivation ಮಾಡ್ತಾ ಹೋಗಬೇಕು ಈಗ, second body the derivation, final velocity derivation. How we can obtain? So by using the same concept, by using this equation number 1 and equation number 2, 1 ಮತ್ತು 2 ಅನ್ನು ನಾವು ತಗೊಳ್ತಾ ಹೋಗಬೇಕು ಈಗ. So I will write the one formula obtained here. So we obtain one answer, that is v1f, that should be equal to m1 minus m2 by m1 plus m2 into v1i. We obtain the one equation here. Similarly we have to obtain the formula for the v2f now. We have to derive. So for that let us consider the concept here. I will using here. ನಾವು ಈಗ ಎರಡನೇ ಇಕ್ವೇಷನ್ ಡಿರೈವ್ ಮಾಡ್ತಾ ಹೋಗ್ಲಿಕ್ಕೆ ಈಗ ನಮಗೆ ಯಾವುದು ಬೇಕಾಗೋದು, ಈಗ v2f ನ ವ್ಯಾಲ್ಯೂ ಬೇಕಾಗೋದು. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಡಿರೈವ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದಿ v2f ನಿಮಗೆ ಬೇಕೀಗ. v2f ಅನ್ನು ಬೇಕು ಅಂತಿದ್ರೆ, ಸೇ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಇಕ್ವೇಷನ್ v2f ಗೆ ನೀವು ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ರೆ v2f ಗೆ ನಮಗೆ ಬೇಕಾಗೋದು. ಹಾಗಾದರೆ v1f ಗೆ ನೀವು ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ದಾರೆ, ಇದನ್ನು ಈ ಕಡೆ ತಂದರೆ v2f minus v1i. Now consider this equation from equation number 1. From equation number 1 we can write it as m1 v1i, okay, minus m1 we have to obtain the formula for the v2f. So v2f ನಮಗೆ ಹಾಗೆ ಬೇಕಾದ್ರು, v2f ಅನ್ನು ಹಾಗೆ ಇಟ್ಕೊಳ್ಬೇಕು. v1f ಗೆ ಈಗ v1f ಗೆ ನಾವು ಇದನ್ನು ಹಾಕ್ಬೋದು ಈಗ, v1f equation ಇದರಲ್ಲಿ v1f can be written as v2f minus v1i, v2f minus v1i, that should be equal to m2 v2f, m2 v2f. ಇದೆಲ್ಲ ಬರೆದು ಕಲಿಬೇಕು, ಬರೆದು ಕಲಿತ್ರೆ ಮಾತ್ರ ಇದು ಎಫೆಕ್ಟಿವ್ ಅಂತ ಕಾಣ್ತದೆ ನಿಮಗೆ. ಸೊ ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೊರಟ್ರೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ನೆಕ್ಸ್ಟ್. ಸೊ m1 v1i ಮೈನಸ್ m1 ನೋಡಿ m1 v2f ಪ್ಲಸ್ m1 v1i, that should be equal to m2 v2f. So Now here the terms, this term as well as this one, they are identical, and taking this term as well as here, they are not identical. Here minus m1 v2f, here m2 v2f, taking that term to the right side. So I will write here, that should be equal to, so m1 v1i plus m1 v1i, we get 2 m1 v1i. That should be equal to, taking this term to the right side, so we can write it as m1 v2f plus m2 v2f. So therefore, which implies here v2f is common into m1 plus m2, that should be equal to 2 times m1 v1i. So therefore v2f formula ಬರೆದಿದ್ರೆ ಹೇಗಾಗ್ತದಾಗ v2f ಗೆ ಫಾರ್ಮುಲಾ ಇದನ್ನ ಈ ಸೈಡ್ ತರಬೇಕಾಗ 2m1 by m1 plus m2 ಅದು into which term v1i, the into v1i. So this is a final equation. So therefore v2f formula, final velocity of a second body, that is given by the formula, that should be equal to 2m1 divided by m1 plus m2 into v1i. So this is a final equation. So therefore final equation obtained here, the formula obtained here in this case is given by 2m1 divided by m1 plus m2 ಅದು into v1i. So this is first equation is this one, second equation is this one. So we have to remember both the formula, ಎರಡು ಫಾರ್ಮುಲಾವನ್ನು ಕೂಡ ಕರೆಕ್ಟಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಸೊ ಎರಡು ಫಾರ್ಮುಲಾ ಕೂಡ ಸರಿಯಾಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಆವಾಗ ನಿಮಗೆ ಫೈನಲ್ ವೆಲಾಸಿಟಿ both the bodies. Final velocity of both the bodies, that is given by the formula, one formula v1f, that should be equal to m1 minus m2 by m1 plus m2 into v1i, and second equation v2f, that is given by the formula 2m1 divided by m1 plus m2 into v1i. So this is a final velocity of two bodies in case of a completely elastic collision. ನಾವು ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಹೋದದಂದ್ರೆ, ಒಂದು ಮೊಮೆಂಟಮ್ನ ಕಾನ್ಸೆಪ್ಟ್, ಅಲ್ಲಿ ನಿಮಗೆ ಸಿಗುವಂಥ ಮೊಮೆಂಟಮ್ನ ಇಕ್ವೇಷನ್ ಸ್ವಲ್ಪ ರೀಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡಿಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೋಗಲಿಕ್ಕೆ. ಮತ್ತೊಂದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸೆಪ್ಟ್. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸೆಪ್ಟಲ್ಲಿ ಮತ್ತೆ ಅದನ್ನು ಜಸ್ಟ್ ಒಮ್ಮೆ ಇದು ಟೋಟಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬಿಫೋರ್ ದ ಕೊಲಿಷನ್, ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು ಟೋಟಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ಟರ್ ದ ಕೊಲಿಷನ್. ಆ ಕೇಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಮತ್ತೆ ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೊರಟದು. ಜಸ್ಟ್ ನೋಡಿಕೊಳ್ಳಿ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಸ್ಟೆಪ್ಸ್ ಇದು. ಹಾಫ್ ಆಫ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್, ಟೇಕಿಂಗ್ m1 ಎಸ್ ಔಟ್ ಸೈಡ್ ಆ್ಯಂಡ್ ಹಿಯರ್ a square minus b square, ಆ ಫಾರ್ಮುಲಾ ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೋಗೋದು. a square minus b square is nothing but a plus b into a minus b. ಸೊ ಎಲ್ಲೆಲ್ಲಿ ಬರ್ತಿದೆ. ಸೊ therefore ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೋಗುವಾಗ ಹೀಗೆ ಸಿಕ್ಕಿದೆ ಇಕ್ವೇಷನ್ v1i plus v1f, that should be equal to v2f. And by using this equation by substituting this equation in equation number 1, we obtain the required format. ಸೊ ಇದನ್ನು ನೀವು ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೋಗಲಿಕ್ಕೆ. ಸೊ ಆವಾಗ ನಿಮಗೆ v1f ಇದು ಒಂದು ಫಾರ್ಮುಲಾ ಬರ್ತದೆ, ಇನ್ನೊಂದು v2f ಇದೊಂದು ಫಾರ್ಮುಲಾ ಬರ್ತದೆ. So we have to remember the final velocity of two bodies during completely elastic collision. ಇದು 5 ಮಾರ್ಕ್ಗೆ ಕೇಳುವಂಥ ಕ್ವಶನ್. ನಾವು ಇಲ್ಲಿ ಒಂದು ಅಸ್ಯೂಮ್ ಮಾಡಿದ್ದೇವೆ ಅಂತ ಅಂದರೆ θ1 and θ2 both are equal to 0. We are assuming that θ1 and θ2 both is equal to 0. That means they are moving along a straight line. ನಾವು ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಹೋಗ್ತಾ ಉಂಟು ಅಂತ ನಾವು ಅಸ್ಯೂಮ್ ಮಾಡಿಕೊಂಡು ಡಿರೈವೇಷನ್ ಮಾಡ್ತಾ ಹೋದ್ದು, ಆವಾಗ ನಿಮಗೆ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್ ಇಕ್ವೇಷನ್ ಸಿಗ್ತದೆ. ಇದು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್. ನೆಕ್ಸ್ಟ್, ಸೊ ಇದು 5 ಮಾರ್ಕ್ಗೆ ಹೇಳ್ತಾರೆ, ಕರೆಕ್ಟಾಗಿ ಇದನ್ನು ಕಲ್ತುಕೊಳ್ಬೇಕು. ಆ್ಯಂಡ್ ಇನ್ನೊಂದು, ಇಲ್ಲಿಗೆ ನಮಗೆ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬಂತು, ಮೊಮೆಂಟಮ್ ಮತ್ತು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಂತ. ಸೊ ಹಿಯರ್ ಬೋತ್ ಆರ್ ಕನ್ಸರ್ವ್ಡ್ ಇನ್ ದಿಸ್ ಕೇಸ್. ಆ್ಯಂಡ್ ದರ್ ಈಸ್ ಒಂದು ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆ್ಯಂಡ್ ಮೊಮೆಂಟಮ್. ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ದ ಮೊಮೆಂಟಮ್ ಆ್ಯಂಡ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, ಇದು ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮಲ್ಲಿ ಒಂದು ಬೇಕಾಗ್ತದೆ ಈ ಫಾರ್ಮುಲಾ. The relation between the momentum and kinetic energy, that should be equal to E, that should be equal to P square by 2m. This is a formula. Relationship between the momentum and kinetic energy, that is given by the formula E is equal to P square by 2m. Here E is nothing but kinetic energy and P is nothing but momentum and m is the mass of the body. ಅದು ಆ್ಯಕ್ಚುಲಿ ಡಿರೈವೇಷನ್ ಮಾಡಿದ ಮೆಥಡ್ಸ್ ಹೇಗೆ ಅಂತ ಹೇಳಿಬಿಟ್ಟೆ ನಾನು. ಸೊ ಡಿರೈವೇಷನ್ ಇಸ್ ಲೈಕ್ ದಿಸ್. ವಿ ಹ್ಯಾವ್ ದಿ ಫಾರ್ಮುಲಾ ಫಾರ್ ದಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. I will take and say E is equal to half into m into v square. So take here bring the 2e to left side, 2e that should be equal to m into v square, multiplying by m on both sides, so we can write it as 2me that should be equal to m square v square, but this can be written as me whole square that should be equal to p square that should be equal to 2me, or you can write it as e is equal to p square by 2m. So this is our formula. So therefore relationship between the momentum and kinetic energy that is given by formula this one, idu ondu, athava idannu hige sa baribodu, or this can also be written as p is equal to square root of 2 into m into e, hige sa baribodu. ಯಾಕಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಆಗ p ಗೆ ನೀವು ಫಾರ್ಮುಲಾ ಬರೆಯುವಾಗ root of 2me. So therefore we have to remember these two equations, one is this one and second one is this one. So relationship between the kinetic energy and momentum that is given by E is equal to p square by 2m or p is equal to square root of 2me. ಈ ಫಾರ್ಮುಲಾ ನಿಮಗೆ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬೇಕಾಗ್ತದೆ. ಈಗ ಸಪೋಸ್ ಈಗ ಒಂದು ಕ್ವಶನ್ ಉಂಟು. ಈಗ ಸಪೋಸ್ ಇಫ್ ದ ಹೆವಿಯರ್ ಬಾಡಿ ಅಂಡ್ ಲೈಟರ್ ಬಾಡಿ ಬೋತ್ ವಿಲ್ ಹ್ಯಾವ್ ದಿ ಸೇಮ್ ಮೊಮೆಂಟಮ್, ಹೆವಿಯರ್ ಬಾಡಿ ಮತ್ತು ಲೈಟರ್ ಬಾಡಿ ಎರಡಕ್ಕೂ ಕೂಡ ಮೊಮೆಂಟಮ್ ಸೇಮ್ ಇದ್ರೆ ವಿಚ್ ಒನ್ ವಿಲ್ ಹ್ಯಾವ್ ದಿ ಮೋರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ? ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡ್ತೀರಿ ಇದು ನೋಡಿ. ಅದಕ್ಕೋಸ್ಕರ ಈ ಫಾರ್ಮುಲಾ E is equal to p square by 2m ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. And heavier body and lighter body both will have the same momentum, therefore p is the same, p is constant, isn't it? So ಹಾಗಾಗಿ ನೀವೀಗ ಈ ಫಾರ್ಮುಲಾ ಈಗ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಹೊರಟ್ರೆ, ಈಗ I will write it here. So we have the two types of body, one is a heavier body and another is a lighter body. Heavier body and lighter body both have same momentum. If both the bodies will have the same momentum, then which one will have the more kinetic energy? So by using this equation, E is equal to p square by 2m, ಎರಡಕ್ಕೂ ಮೊಮೆಂಟಮ್ ಒಂದೇ, ಹಾಗಾಗಿ p is constant, hence here p is constant, p is a constant term. So therefore the kinetic energy is decided by the mass of the body. So E is inversely proportional to the mass. If the mass is more, then that kinetic energy will be less. ಆವಾಗ ಆ ಬಾಡಿದ್ದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅವಾಗ ಲೆಸ್ ಇರ್ತದೆ, ಯಾಕಂದರೆ ಡಿನಾಮಿನೇಟರ್ ಜಾಸ್ತಿ ಇದ್ದರೆ ಆವಾಗ ಸಿಗುವಂಥ ಆನ್ಸರ್ ನಿಮಗೆ ಕಡಿಮೆ ಸಿಗೋದು. ಸೊ ದ್ಯಾರ್ಫೋರ್ ನಿಮಗೆ ಡಿನಾಮಿನೇಟರ್ ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ಇದ್ದರೆ ಆವಾಗ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಹೈ ಇರ್ತದೆ. So therefore we can say that lighter body will have the less mass and hence lighter body will have the more kinetic energy. So therefore in this question, if the heavier body and lighter body will have both will have the same momentum, then in that case the lighter body will have the more value of kinetic energy. So ಅದಕ್ಕೋಸ್ಕರ ನಿಮಗೆ ಈ ಒಂದು ಫಾರ್ಮುಲಾ, ಸೊ E is equal to p square by 2m, ಆ ಒಂದು ಫಾರ್ಮುಲಾವನ್ನು ಕ್ಲಿಯರ್ ಆಗಿ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. ಈಗ ಇನ್ನೊಂದು ಕ್ವಶನ್, ಈಗ ಇದರಲ್ಲೇ ಸಂಬಂಧ ಹೊರಟದ್ದು. ಸಪೋಸ್ ಇಫ್ ಹ್ಯಾವ್ ಎ ಹೆವಿಯರ್ ಬಾಡಿ ಆ್ಯಂಡ್ ಲೈಟರ್ ಬಾಡಿ ಬೋತ್ ವಿಲ್ ಹ್ಯಾವ್ ದಿ ಸೇಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. Another case, heavier body and lighter body. If the heavier body and lighter body both have same kinetic energy, then which body will have the more momentum? Then which body have more momentum? So question is like this, which body will have the more momentum? ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಿ ಈಗ? Now heavier body and lighter body both will have the same kinetic energy. So by using the equation here, so I will have the another equation, p is equal to square root of 2e into m into e. P is equal to square root of 2me. So here the same kinetic energy, E is constant, both will have the same kinetic energy. Kinetic energy ಎರಡರದ್ದು ಕೂಡ ಒಂದೇ, ಹಾಗಾಗಿ E value will be same. So E is same ಆದರೆ E is constant. So therefore we can say that. So here the E value is constant. So here E is constant. If E is constant, then momentum is decided by mass of the body. Momentum is directly proportional to the root m. If m is more, then momentum is also more, isn't it? So therefore heavier body will have the more momentum and lighter body will have the lesser momentum. So in this case, ಹಾಗಾಗಿ ನಮಗೆ ಈ ಕೇಸಲ್ಲಿ which body will have the more momentum ಅಂತ ಕೇಳಿದರೆ heavier body will have the more momentum. So in this way we can determine the which body will have the more momentum or which body will have the more value of kinetic energy. So ಅದಕ್ಕೋಸ್ಕರ ನಿಮಗೆ ಈ ಫಾರ್ಮುಲಾ either this one ಅಥವಾ this one ಈ ಎರಡು ಫಾರ್ಮುಲಾ ಇದನ್ನು ಫಾರ್ಮುಲಾ ಲಿಸ್ಟಲ್ಲಿ ಈಗಲೇ ಇವತ್ತೇ ಆ್ಯಡ್ ಮಾಡಿ. ಸೊ ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ದ ಮೊಮೆಂಟಮ್ ಆ್ಯಂಡ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ದ ಫಾರ್ಮುಲಾ E is equal to p square by 2m or p equal to square root of 2 into m into E, where p is the momentum of the body, m is the mass of the body and E is the kinetic energy. ಅದು ಆ್ಯಕ್ಚುಲಿ ಡಿರೈವೇಷನ್ ಮಾಡಿದ ಮೆಥಡ್ಸ್ ಹೀಗೆ. ಸೊ ಈ ಥರ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ನಾವು ಡಿರೈವೇಷನ್ ಮಾಡಿಕೊಂಡು ಹೋದ್ದು. ದಿಸ್ ಇಸ್ ಅ ಫೈನಲ್ ಇಕ್ವೇಷನ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟಲ್ಲಿ ಇವತ್ತು ಆ್ಯಡ್ ಮಾಡಿ. ಸೊ E is equal to p square by 2m or p is equal to square root of 2m. And we obtain the two equations, that is the final velocity of a two bodies in case of a elastic collision. Elastic collision ಎರಡು ಇಕ್ವೇಷನ್ ಬಂತು, ಆಗಸ್ಟ್ ನಾವು ಡಿರೈವೇಷನ್ ಮಾಡಿಕೊಂಡು ಹೋದ್ದು. one is for the V1F and another one is for the V2F. Hope you understood this derivation. Thank you.